Hello, Mr. Sutton here, bringing you the IM3 Chapter 3 Post-Quiz Extra Practice Number 4 Solutions on Review of Mixed Factoring. There's a puzzle that goes along with this, or at least a worksheet. Let me show that to you. So here's the worksheet that goes along with this review assignment. So we've got a whole bunch of factoring problems, 9 of them to be precise. They kind of run the gamut from fairly easy to a little bit crazy. They tell us to watch out for GCFs. There's no puzzle to really solve. We just got to gut through these and get them done. So please join me on our quest to do so. Here we go with our opening problem on this one. I noticed that I don't have a 1x squared out in front, so I'm going to try to take out a common factor. Between 24, 28, and 12, I believe I can take a 4 out of all of those, leaving me with a 6x squared minus 7x minus 3. And now, since the stuff inside does not have an x squared coefficient of 1, and since there's no perfect square shortcuts I can use, I'll use my AC method. So 6 times negative 3 gives me an AC value of negative 18. And I'm looking for factors of negative 18 that add up to negative 7. 1 and 18 doesn't work. 2 and 9 works if I have positive 2 and negative 9. So I can break this up into a 2x minus 9x in the middle. That's my only change there. Next, I'm going to use grouping on the 4 terms inside. So I'll take out a 4 here, or at least I already had one taken out. The next 2 terms, I can take out a 2x, leaving me with 3x plus 1. And the last 2 terms, I can take a negative and a 3 out of all that, leaving me with 3x plus 1. The 4 is still there from before. I can take out my 3x plus 1 now as a common factor, and then 2x minus 3 is my leftovers factor. And that's it for that one. This next problem is a little bit trickier because you might look at this and say, oh, hold on a sec. I have 2 perfect squares. I can use my perfect square shortcut. Before you jump in and do that, however, always look to see if you can take out a common factor, because if you don't do it in the beginning, you're going to have to do it in the end anyway to fully factor this. So looking at this, we can take out an 81 from both of those, leaving me with x to the 4th minus 1. And now we can still use our perfect square shortcut. That would be the a squared minus b squared shortcut on all that stuff in there, but I can use it on a smaller subset instead of the entire original expression. So I've got my 81 that I already took out, and the square root of x to the 4th, that's going to be x squared. Square root of 1 is 1, so I have x squared plus 1 and x squared minus 1 using this shortcut over here. That's pretty good as far as it goes, but I can do a little bit better with that x squared minus 1. So the 81, the x squared plus 1, can't do anything there. But I can use this a squared minus b squared shortcut again on x squared minus 1. Square root of x squared is x. Square root of 1 is still 1, so x plus 1, and then x minus 1. And that is as factored as it's going to get. For number 3, taking a look at all of these, it doesn't look like I can take out any common factors in the beginning. Since I have 4 terms, I'm going to go straight to grouping on this one. My first 2 terms, I can take out an x squared from those, leaving me with a 2x minus 3. And I have a negative 3rd term, so I'm going to take a negative out for the next 2 terms. Negative 4 comes out of 8 and 12. So that leaves me with 2x minus 3. 2x minus 3 is now a common factor that I can take out of everything. And that leaves me my leftovers parentheses of x squared minus 4. Now before I just call this a day, x squared minus 4 can actually be split up using my a squared minus b squared shortcut. So I've got the 2x minus 3 that I already factored out. I can't do anything more with that. But again, I can use my x squared a squared minus b squared, so I'm going to take the square root of these 2 things and basically put a plus and a minus parentheses. So I have x plus the square root of 4 plus 2, and then x minus 2. On this problem, we have 3 terms, starting with an x to the 4th, then we have an x squared and a constant. This is actually something in quadratic form, so although we can't treat it exactly like a quadratic, we can use quadratic techniques on it, and we're going to end up with an x squared instead of an x when we do that. So I'm just going to look to factor this kind of regularly, asking what multiplies to 9 and adds up to negative 10. So 1 and 9 would actually do the job if it was negative 1 and negative 9. So I'm going to split this up. Instead of using an x, I'm going to use an x squared. So x squared minus 1 and x squared minus 9. This is great as far as it goes, but I can break these up even further using my a squared minus b squared shortcut, a plus b, a minus b. So basically square root each thing and put a plus and minus parentheses. The square root of x squared is x, plus the square root of 1 is 1. So we have x plus 1 and then x minus 1. For the next one, we have square root of x squared, still x. Square root of 9 is 3, so plus 3. And that means we have x plus 3 and x minus 3. And this is as factored as it gets. For this one, I'm going to try to take out a common factor. Really, the best I could be able to do here is 7. If I take a 7 out of these, that gives me just an x cubed. And 189 is divisible by 7. You could think of this as being like 140 plus 49. And that would be, if you divided those by 7, you'd have like 20 plus 7, so 27. Or you could use a calculator, either way. But now I notice that I have a sum of two perfect cubes here. So I can use this perfect cube sum formula, a cubed plus b cubed, and then a plus b, a squared minus ab plus b squared, one of our magic formulas here. So I've got the 7 I took out initially, and now the a and the b, I get those by cube rooting the things in this parentheses here. So a is the cube root of x cubed, or just x, plus b is the cube root of 27, which is 3. And next, a squared really means x squared on this one, and ab that I'm subtracting means 3 times x, so minus 3x. And then finally, b squared, that's going to be 3 squared, so 9. And that's as good as it's going to get. On this problem, I noticed that we've got 4 terms, so definitely grouping seems like a good one for this. Before I dive right into grouping, though, I always check to see if there are common factors. It looks like these are all divisible by 5, so let me take that out. That leaves me with x cubed plus 2x squared minus 3x minus 6. And now I'm going to use grouping on the 4 things left inside. So the 5 came out already. For the next 2 terms, I can take out an x squared. That leaves me with x plus 2. And then for the last 2 terms, it looks like negative 3 comes out of those, leaving me with an x and a plus 2 again. So I still have that 5 I took out right away. Now I have the x plus 2 common factor coming out. And finally, this x squared minus 3 can come out as its own factor. Just taking a quick look at this x squared minus 3, this is not the difference of 2 perfect squares, so I can't factor this any further, and I'm done. For number 7, looking to see if I can take out some common factors, it looks like I'm out of luck here. So we're going to have to go to AC method or guess and check or something here. So let me do AC, 14 times negative 15. And let me think here. Well, 15 times 15 would be 225, so 15 less than that is negative 210 for my AC value. So now I need factors of negative 210 that add up to 29. Oh, this is going to be fun. All right, so 1 and 210 won't work. 2 and 105, definitely not. 3 goes into that 70 times. That's not going to get me a 29. 4 does not go in there. 5 will go in there. Let's see, we got 5 times, I think, 42. That's not going to get me to 29, but I'm at least getting closer as my factors get closer together. 6, does 6 go in there? I feel like it should because 2 and 3 both go in there. So let me think. 6 times 35? Let's see, that would be 180 plus 30. Yep, 6 times 35. Hold on a second. I think I found it. Negative 6, positive 35. That would get me 29. So we got 14x squared minus 6x plus 35x minus 15. Okay, I think we can work with this. So I'm going to go to grouping now since I've got 4 terms. So first 2 terms, I can take out an x and a 2, so 2x. That leaves me with 7x minus 3. For my next 2 terms, I can definitely take a 5 out of those. That's going to be 7x minus 3. So 7x minus 3 comes out. 2x plus 5 goes in. And that's as good as it's going to get because we're down to x to the first power there. This next one is going to be a little bit crazy when you see the final answer. So very first thing I can do, these are both even coefficients, so let's take out a 2. That leaves me with x to the 8th minus, this will be 256. Now, x to the 8th, because it has an even exponent, counts as a perfect square. 256 is also a perfect square. It's really 16 squared, but you could use a calculator to verify that. So I'm going to use my a squared minus b squared shortcut, where I essentially square root these two things and stick them in a parentheses with a plus and a minus. So we have the 2 that we took out, and then the square root of x to the 8th, we have to divide the exponent by 2. So that's x to the 4th. Square root of 256, we already said that was 16. So we have x to the 4th plus 16 and x to the 4th minus 16. Now this 2 and this x to the 4th plus 16 can't be dealt with any further. Those are as factored as they're going to get. But this next thing, x to the 4th minus 16, is just another case of a squared minus b squared. The square root of a to the 4, or x to the 4th, is going to be x squared. Square root of 16 is 4, so x squared plus 4 and x squared minus 4. But wait, there's more. We've still got the 2, we've still got the x to the 4th parentheses and this x squared plus 4. But this x squared minus 4 is another a squared minus b squared. We just get to keep spamming this shortcut for this entire problem. Square root of x squared is x, square root of 4 is 2, so x plus 2 and x minus 2, and I promise now we're done with this one. For our final boss battle, this is truly one worthy of final boss battle music, if I had any. We've got some fractional coefficients here, but they still expect us to factor this thing. So what I'm going to try to do is get rid of my fractions. To do that, I'm going to be really crazy, and I'm going to factor a 1/2 out of this whole thing. Because I noticed that 2 of these have denominators of 2, and the one that doesn't, well, I don't really care. So if I divide 3/2 by 1/2, that'll give me a 3 x squared. 4 divided by 1/2, we're really multiplying by the reciprocal, which is 2. So this would be a plus 8x. And then negative 35 over 2 divided by 1 over 2 is just going to be minus 35. For the stuff inside, there isn't really much more to do except to try to use the AC method on that. So 3 times negative 35, that's negative 105. So I'm looking for factors of negative 105 that add up to 8. Well, I don't know a whole lot of factors of 105, but I don't think there's that many to begin with, since it's an odd number. So 1 and 105 definitely doesn't work. 3 goes into 105 because the digits add up to a multiple of 3. How many times? Let's see, well, 3 goes into 99 33 times, so 35 would be the number of times 3 goes in there. I guess that makes sense. Hey, 3 times 35, that's how we got it in the first place. Duh. But that's not going to get us 8. So we keep searching. 5 definitely goes in there. 5 and 21, I believe. 5 and 21. Still can't get an 8 out of that, though. That would give us a 16 if we subtracted. All right, what else? 6. 6 doesn't go into there because even numbers don't go into that. 7. Well, 7 goes, I happen to know 7 goes into 98 because that's 49 times 2. So if it goes into 98 14 times, then it would go 15 times into this 105. So 7 and 15. That gives me an 8 if I have negative 7 and positive 15. So let me split this up now into minus 7x plus 15x for that middle term. And at this point I can use my factoring by grouping approach. So the 1/2 is still there. For the first 2 terms inside, I can take out an x, leaving me with 3x minus 7. And for the 15 and the 35, those are both divisible by 5, leaving me again with 3x minus 7. The 1/2 is still there in all its glory. We can also take out a 3x minus 7 from everything, and that leaves the x plus 5 for my last factor. There it is.